This is a $200,000 robotics masterpiece. We reached out to our friends in the industry and we bought, begged, borrowed, and stole a whole bunch of robots to see how they stack up for their price. So if this is the top of the line, where's the bottom? Ta-da! Here is our cheapest robot. You can get all of these parts all together for about $1. It has a motion system, these syringes, has a power source, my hand, and it has a structure, all the balsa wood. By pushing the syringes, fluid moves down the lines, making the joints actually move up and down. It's not building a car anytime soon, but it is a fun and cheap way to explore some basic robotics concepts. Our next robot is a big jump to $115. That's over 100 times the price of our last one. This is the SparkFun Experiential Robotics Platform, or XRP. It's a kit that teaches the basics of robotics. It's got everything you need to build a small rover. Honestly, this is kind of my jam. Yeah, no, I'm actually very happy with this. I'm good at programming a lot of things, but I'm not certain that mobile robots are one of those. Okay, it's all assembled. Now I just need to figure out how to program it, which should be pretty easy. How this works is you have a motor on either side and a pair of reflectance sensors, and those can detect where they are relative to this black line that we've taped down onto the table. Takes the data from those two sensors, combines it, takes the difference, and uses that to control the speed that the two motors are running at. It's fun, it's accessible, and it's what's going to inspire the next generation of engineers and makers. At $500, we're entering the realm of serious robotics. $500 is a significant chunk of change, but what does it get you? Well, it got us this. This is the $500 robot arm that Bogdan convinced us to buy. It's been part of the Hacksmith family for ages. We found it on Kijiji, Canadian Craigslist, where it had been listed as an old injection molding arm used to make buoys. Bogdan tried to resurrect it, but he found that the specialized cables it needed were really expensive and really hard to find. So it kind of just sat there as a statue. But it did find a purpose. So now it's in our front lobby, just inside the door, and signed by everyone, really. A plasma channel, G3R, Full Metal Engineer, and of course, Colin Furs was here. It's pretty cool. This next robot is something a bit more familiar. This is a robot vacuum cleaner, specifically the Saros Z70. You might recognize it from CES 2025, where it was kind of a bit of a hit. What makes it so special? Well, it has an arm, and we'll get back to why that's so important later. But for now, let's look into the past to understand what's going on here. Robot vacuums have been around for decades. Since 1996, actually. They clean floors, but often collided with objects and struggled to navigate walls and obstacles. That was 29 years ago. So, how far has this technology come? We've been testing the Saros Z70 in the office for the past couple days, keeping a close eye on its performance. So far, it does what a vacuum is supposed to do. It still has wheels, motors, and bristles, but the real leap forward lies in the sensors and the software. Where the original robot vacuum blindly bumped its way through a room, today's models use advanced LiDAR sensors to map entire spaces. They know where they are, where they've been, and where they need to go next. Who's in the house, where you are, what you're doing, your credit card information, and your deep, dark desires. Obviously, I'm joking. The Saros Z70's unique feature is its arm. This is really the first of its kind. It can pick up objects and move them out of its way so it can keep cleaning. You can see how these machines are already starting to look a little bit like those robotic assistants that we all thought we would have after decades of sci-fi movies telling us we would, that would fold our laundry and make us coffee. We're almost there. Next up is man's best friend, but these ones aren't gonna move to a farm upstate. This is the Unitree Go 1 Robot Dog, coming in at $2,700. Animatronic good boys like this have been taking the world by storm since Boston Dynamics unveiled Spot. They're eerily lifelike in their motion, which is a testament to the incredible engineering going on under the Stormtrooper carapace. Ours is named Princess, and she has some really cool features. The Go 1 can hit speeds of up to 17 kilometers an hour, making it one of the fastest robots in its class. It's designed for everything from research to light industrial tasks, or mostly just showing off to your friends. It can navigate tricky terrain with ease, perfectly placing every footstep to avoid wiping out. It's the perfect robot if you've always wanted a robot that acts like a loyal sidekick. It can carry small payloads too. It's not going to get all your groceries in one trip, but for small deliveries of research equipment, it's got you covered. Oh. Anyone like a drink?
A Red Bull Berry! Hey! All right, I'm in. Our hero.
Look at that. Oh my lord. Look at that.
Oh yeah.
Oh, even cold. Oh, nice.
Thank you.
Red Bull delivery.
Care for a drink?
Best use of the dog yet.
At $2,700, the Unitree Go 1 packs an incredible amount of advanced robotics in a relatively affordable package. But wait until you see this next robot. I bet your lawnmower can't do this! Robotic vacuum cleaners are dealing with my indoor chores, but what about my outdoor chores? Like cutting the grass? How do I automate that? There are a whole lot of lawn mowing robots out there, and they all have varying levels of autonomy. The first ever commercial lawn mowing robot came out in 1969. It weighed 125 pounds and had a runtime of 3 hours or 3,000 square feet. Not bad, but it didn't look like the most reliable thing ever. 56 years later, we have the modern version. The Momotion Luba 2 all-wheel drive, and its compact counterpart, the Luba Mini all-wheel drive. These things have tons of fascinating new tech built into them. As you can see, they can even cut 3D patterns into your lawn. So naturally, we branded the grass. So what have 6 decades of mower R&D gotten us? Well, it's cheaper now, for a start. The great-grandfather of all autonomous lawnmowers was $800 in 1969, or almost $7 grand in 2025 money. This is only $4,000, and it gets the same runtime while weighing 1/3 as much. Mind my toes there, buddy. And with all the autonomy and smarts that they've packed into it, you never need to actually plug it in when it's done. It can navigate its way back to the charging point fully autonomously. In theory, in the time it takes you to mow your lawn once manually, you can set up your robots to do it and never have to mow it again. It can handle slopes up to 38.6 degrees. It also has adaptive suspension and omni wheels, which really feel like something out of an early 2000s Will Smith movie. So what do you think? How long is it until everyone's mowing their lawn with one of these, or rather, everyone's not mowing their lawn with one of these? Let me know down below. When I say robot, what comes to mind? R2-D2? Wall-E? Well, this next robot has that same energy. This is Diablo, the world's first direct-drive, self-balancing wheeled leg robot. By putting high-powered drive wheels on the ends of its legs, this thing was designed to move with agility and precision. It can handle rough terrain, balance effortlessly, and handle pretty much anything you throw at it. It's also incredibly silent.
Holy Holy Bro, that thing is dead silent.
Now, Charles, you might be asking, what are people doing with these amazingly advanced, surprisingly inexpensive robots? Well, the answer is, I don't know. What's their customer base? What is their purpose? They don't even pass the butter.
What is my purpose?
You pass butter.
There have been real uses for Spot, doing remote inspection of heavy industry sites, as Tom Scott showed us in 2021. And I guess one guy did put a flamethrower on his Go 1. Oh, also, everybody seems to want to put guns on these things, and all of the companies making them have government backing. So, you know, there's that. And the Diablo exists, so the engineers at Direct Drive Tech can flex their top-notch servo design. They don't need to sell you one of these as a cool toy, though they're happy to.
That's cool!
They want to sell robotics engineers their high-tech direct drive servo motors, and the Diablo is really just them showing it off so that other people can find uses for it. So what's to be done if you're ready to build something on a properly robust robot that won't, say, get its foot stuck between rocks, or run out of battery and faceplant all your gear directly into the pavement? Well, $10,000 is where this video starts to take a turn. You might recognize this robot because we've teamed up with the gang at ClearPath Robotics before on some projects. This is the ClearPath Husky. What makes this worth $10,000? The Husky is built for research and industry. It's a super robust bot with a solid chassis and a super powerful drivetrain. So it can cover pretty much any terrain, from grass to gravel to that one awkward slope in the back corner of the lot. Now you might recognize it from that time we had it set up as our robot butler back at the old shop.
Hey Jarvis, make me a coffee. Thanks, dummy. Just the way I like it.
But what really sets it apart is its capacity. You can strap a lot of gear to any sort of robot, but you can't necessarily sit on one and ride it around. It's not gonna get stuck, roll over, or flip, and drop all your expensive gear on the ground. Or your video host, for that matter. At $10,000, this isn't the most expensive robot on the list, but it might be the most versatile. But it's not the most handy. For that, we're gonna need to go up a tier. While I was outside on the Husky, James was putting together something really cool to show you guys.
Now we're up to $15,000 with a Unitree Z1. You might remember this arm from our forearms video. And since then, I've actually gotten into C++ programming with a little help from ChatGPT, and now I have a pretty awesome robotics program that lets me use this device. It's called the Happily Inverse 3, and we actually discovered it at CES earlier this year. And it's basically a 3D mouse, but it also has force feedback and haptic feedback. What my program does is it takes the location of this and sends it to the robot arm. But what's really cool is when the robot encounters a force, I actually feel it back here, which allows you to have extremely intuitive control of the robot. If we add a recording macro, I can basically do a task, such as standing apart, spray painting apart, even welding apart, and play it back. And while I've gotten something here working quite well, I need something better. Dave's actually been testing a few other robot arms that are much more affordable, and if they work well, you might be seeing some Hacksmith Industries branded robots coming soon. My goal is to make different end effectors, that's the gripper, the tool head, and make a general purpose robot arm that anyone can use and automate tasks in the workshop. How long has robotics been around for anyway? 30 years? 40 years? No, 64 years. And you used to need to be an expert in robotics to even set something up. In 1961, Joseph Engelberger and George Devil from Unimate unveiled the very first industrial robot arm, marking a milestone in automation. By the 80s, more versatile robots emerged capable of handling a broader spectrum of applications. Which brings us to today, where I get to introduce this little guy. This is the Microbot Teach Mover, an educational robot arm introduced in the 1980s. The crazy thing is, it still works. You'd have a teach pendant like this, program in the moves, and then you just hit go. That's actually kind of how my program works. It's just a bit more automated. But you clicked on this video to see the pinnacle of robotics. So let's show you that.
Now you might be thinking, surely one of these robots is going to be something that we actually built, right? Well, it's right here. One of our greatest creations, our BattleBot Orbitron. For those who've been following us, you know that Orbitron isn't just another project. It's an engineering masterclass packed into a 250-pound package. The journey began in 2023 when Ben Bogdan and our University of Waterloo student team got the wheels rolling. What started as an ambitious idea has grown into one of the cornerstone series of our channel. And all the episodes are available now if you want to catch up, so I'll link a playlist in the top right. But when it comes to Orbitron, nobody tells the story better than Ben.
Orbitron costs about $40,000 in parts alone. If you count the man hours, it's a lot more than that, but we're gonna say 40. Between the spinners at a couple $1,000s a piece, thousands of dollars in batteries, aluminum, AR500, there's a lot of robot there, and it's fought 7 times in Vegas as a record of 3 and 4, so we can do better, but we're still learning with it. Orbitron has 2 vertical spinners weighing 40 pounds of spinning mass total. It has 4 motors in it, it runs on 16 cell LiPo batteries, has about 100 horsepower of electric power.
I'm glad we moved the robot lawnmower.
I'm very glad.
Oh!
I crashed my car.
Orbitron is the first AI-controlled BattleBot. We have a camera mounted outside the arena, talking to our outside supercomputer, sending commands to the robot to make it the ultimate fighting machine.
This isn't just a robot. This is a filmmaker's dream brought to life. Meet the Sisu C14, a $140,000 marvel that brings blockbuster-level shots to life. The Sisu C14 is built for one thing: precision. For product shots, this arm helps us capture every detail, making even the smallest components look epic. Take these new bold concept edition mini sabers, for example, which you can check out at hacksmith.store right now. It's what we use for the dramatic beauty shots of our finished projects, painting them in the best possible light. Having a robot arm like the Sisu lets us do shots that otherwise would not be possible, like this lightsaber shot, or this time lapse. So to show just how precise you can get with the Sisu robot arm here, we're gonna do a little demo. Now this is a robot arm just like any other, so you can set really precise keyframes telling it when to be where. And included in that is you can use those keyframes to send external signals to things. So what we wanna do is use one of those external signals to drop a ball bearing in this rake here and have it smash through this champagne flute. And we wanna follow the ball the entire time it's falling and catch this smashing in like 1,000 FPS slow-mo.
Is there a science to this, Charles?
I guess. The science is we want these two things to be in line with one another. 3, 2, 1, 0, 1.
Nice.
Cool. That's our balls dropping. So now to get the camera to track it.
That wasn't right. we're a little slow now. So we just have to move that keyframe a little bit to the right.
So we released the ball at about 200 milliseconds in on the camera. We're a little earlier than that, but we want this motion to happen a little faster.
Fighting gravity here, eh?
Yeah, gravity always wins.
3, 2, 1, go. Yeah, we got it. Safety glasses, here we go. Broken glass, 3, 2, 1. I think we need to get a bigger ball.
So we found that these balls aren't actually heavy enough to, break that when dropped from that height. So we need a bigger ball. We had one of these kicking around in the shop, and this weighs 27 times as much. Let's try that.
3, 2, 1. Nice! Three, 2, 1. Three, 2, 1.
For us, the Sisu C14 isn't just a tool. It's a part of how we share our creativity with the world. At $140,000, it's a big investment. But for filmmakers and creators, that's an investment in quality, storytelling, and content. The Unitree H1, a $200,000 bipedal robot that takes us to the next level of robotics. If you've made it this far into the video, you've seen everything from a $1 syringe robot to the $40,000 Orbitron. But this, right here, is a whole different ballgame. This thing is a leap into the future. What was once a sci-fi dream is now a reality. It's more than just another machine. It's a symbol of where robotics is headed. As soon as we power it up, you feel the difference. It's really lifelike, almost alien to look at or interact with.
Can you help me unload a body?
Yeah, where are we burying it?
Yeah, there's a Terminator in there. You can't drag a body. Holy!
Yeah. Like, I was pushing as hard as I could.
It goes to show how fast this industry is moving. Advancements in manufacturing, efficiency, and competition are driving prices down and capabilities up. Will we see humanoid robots in our households within our lifetimes? With this kind of progress, it's not out of the question. Its modular design makes it highly customizable for various applications, from industrial tasks to research and development. Right out of the gate, we threw it into some real-world tests. Uneven terrain, complex movements, workplace violence.
Fine, just let's put them on this side. Do robots have rights?
No.
Oh my god, I'm gonna get piggyback from a humanoid robot. Oh, he is so heavy. I didn't think I'd be doing that today. Ready to go out like this! Let's drip him out. It passes the person. Get in my face.
The H1 is the perfect example of how robots will shape the future for us as consumers. Imagine a $200,000 robot scaled down and optimized for everyday use. That's what the H1 represents, the bridge between advanced robotics and accessible technology.
What the hell is that?
As robots like this become more prevalent, they'll transform how we work, live, and interact with technology in our daily lives. It's a symbol of where robotics is headed, a $200,000 investment in what could be the future of autonomous robots. From DIY syringe creations to humanoid powerhouses to state-of-the-art cinema robots, the evolution of robotics is mind-blowing. However, once you've crossed a certain threshold in cost, robots become less flashy but exponentially more expensive. Take the Canadarm on the International Space Station, or Google's Waymo, for example. These systems showcase how robotics transitions from visually impressive to functionally indispensable, solving problems on a massive scale. What's cutting edge today could become essential tomorrow, revolutionizing industries and even daily life. Let me know in the comments which robots you like the most, and which ones you'd be the most okay inviting into your house. Thanks for watching. Like, comment, and subscribe, and I'll see you in the next one.